Okay, so this is page 6, example number 2. Here it says divide the specified intervals into 3 subintervals of equal length, then compute. Remember, this means the area under the curve from -2 to 4 of the given function, and this is equivalent to the sum of rectangles 1 to 3 of the width times the height. Okay, so we want to do the left, right, midpoint, and trapezoidal. In order to determine the area under the curve, if it's an over or under approximation, you're going to need the calculator, and they give us the function down here at the bottom. So we're going to go into our calculator, and we're actually going to put this function in here. So we have x cubed, and then we go back to the home screen. We want to find the true area under the curve first, so that we can determine if each one of the methods is an over or under approximation. So we go into alpha window, and it's option number 4. The boundaries are from -2 to 4, and our function is in y sub 1, and this is with respect to x. So the true area is 60. So I'm going to make a note here that our true area, put it right here. Okay, so what we're going to do first is create our table as we did in the previous example. This is x and this is f of x, and we're starting at -2. We do need to find delta x, so delta x is equal to b minus a over n, which in this case is 4 minus a -2 over 3, so that means that our delta x is 2. So if we're starting at -2, our next height value, or x value to calculate the height, is going to be 0, then 2, and our end is 4. So they wanted 3 subintervals, and we have 1 additional value so that we can calculate the left and calculate the right. So this would be f of -2, which is -8. This is f of 0, which is 0, f of 2, which is 8, and then f of 4, which is 64. And remember, I'm getting each one of these values by plugging my x value into my original function of x cubed. You will also need your midpoint, so the midpoint here would be -1. The midpoint here is +1, and the midpoint here is 3. Remember, if you add these two together and divide by 2, you'll get your midpoint. I can actually plug these in and figure out what these are, whether I do it manually or I do it in the calculator. So let's go down here by each graph. I'm not going to go through the graphs, it's not necessary. I'm really more concerned with the calculation of left, right, midpoint, and then our trapezoidal. So the left midpoint setup is going to be delta x, which we calculated as 2, times our left endpoints, which would be f of -2 plus f of 0 plus f of 2. Remember, we only need 3 subintervals. So then this is 2 times -8 plus 0 plus 8. So I have an area of 0. In this case, what this means is that the area above the x-axis and the area below the x-axis under the curve is equivalent, therefore the sum is equal to 0, and this is okay. You cannot assume that the right endpoint area is going to be the same, so we need to conduct our calculation. So this is 2 times, because this represents delta x, and now we are going to be moving from the right. So we're starting over here. This is f of 4 plus f of 2 plus f of 0. So this is 2 times 64 plus 8 plus 0. So we have a total area of 144. Again, this is an approximation. Moving down to our midpoint, we start off with delta x, which is 2, times, we had calculated our midpoints as f of -1 plus f of 1 plus f of 3. Remember, each one of these values is being plugged into x cubed. 2 times negative 1 cubed is negative 1, plus 1 cubed is 1, plus 3 cubed is 27. These two become 0, so 27 times 2 is approximately 54. Okay, our trapezoidal is going to be our left endpoint value plus our right endpoint value divided by 2. So when I added those two together, because this was 0 and then this is 144, this is 144 divided by 2, which is approximately 72.